now. 7B's code is 517468. 517468. Two more, let's go. Two more, let's go. I like the fact it gives you like names that I can't tell who's who. That's fine. I like that. Huh? Okay, how do you make it to period 2 with a dead laptop? Okay, so you need to either be bringing a charger from now on to school. I think. That's funny. Hurry up, come on. Okay, so I'm ready to move on. Shh, hurry up, come on. Because I think I'm just waiting for you. When is parent-teacher interviews, or do I need to make a phone call in advance? You understand what I'm saying though, right? Okay, let's move on. Okay, so we're now looking at sandboxing and cryptography. Let's start. So you're at a coffee shop, free Wi-Fi pops up, your phone warns you that the network's unsecured, you need to pay a bill right now with your banking app. What do you do? Let's go. Come on guys, this should be a really simple question. Thank you Daniel for the dancing, I appreciate it. Okay, stop. Stop. Who said they were going to pay it now on open Wi-Fi?
That's right. I didn't even tell you to put that down. But you pressed it on my computer. It said you have to pay the bill right now.
Okay, stop. Let's talk about the issue with you paying it now on open Wi-Fi. What are some of the issues, guys? Alan, just one.
You could be intercepted by attackers.
Data could be intercepted by attackers. Do you not watch any of those NordVPN ads? There are people creeping everywhere.
You could be intercepted, but if you don't pay it, you're definitely getting a late fee.
Okay, the biggest issue we have, guys, is that although those ads are designed as ways to make people buy stuff they probably don't need, the reality is we know that there is an opportunity for our data to be intercepted, okay? So through this session, we're going to look at encryption, decryption, hashing, and look at the difference between symmetric and asymmetric keys, and then talk about how sandboxing can help us stop malicious code running, okay? Let's get started. So this is an information slide. I don't do a whole lot of them, but you need to go and have a look at what you've got in your notes and check you have this information down. So we know that encryption allows us to turn text into cipher or ciphertext using a key, and the types of things we want to do that for would be things like credit card numbers, any of our personal data that we would not want people to access, okay? Probably the best one would be banking details or credit card numbers. If you do not have examples of that written down, write it down now. Open your books, write it down. In your case, William, type it up, okay? The flip of that is decryption, where we use a key to reverse engineer or reverse encrypt and restore our original data to its original information. Okay? That's what our phone does when the data comes through from a HTTPS site so that we can view it. There are two different ways we can do this, symmetrical and asymmetrical. We're going to talk about what that looks like. Or maybe you can tell me in just a second. Yes?
I got it.
Perfect, I love that. Just a sec when we get there. Anyone ever bought stuff from Foot Locker?
Yeah.
Is it a reputable store? Yeah? Foot Locker.
It's fine.
Okay. Okay, so let's move on. So, we have this idea here of we have a choice when we do a key exchange. We've got a symmetric or an asymmetric key. Both of these are using very strong maths to determine the cipher. Our cipher being that secret code that we're going to use to transform our data. Okay? When we've got symmetric keys, we use one key, the same key. Yes? To transform our data, both encrypt and decrypt it. It's super fast if you've got lots of data, but it's not particularly secure. Okay? In the asymmetric space, we have something called a public and a private key. Okay? Public key encrypts the data and the private key decrypts it, so it turns it back into its original form. By having two keys, the process is much more complicated, but the data is much more secure. Do you have this information down? I don't think you do. Could you check for me, please? Thank you. So notice this slide deck, because it's more complicated, has more information in there than the previous slide deck, which was more about applying. Did you have this down? Come on. Oh, I forgot to start the slide. Oh no, I started. Oh no, did I? No, I did. Sorry, brain snap. Okay, moving on. So I want you to think about the unique and the shared traits, so the common factors, and then the different factors of each encryption type. You reckon you know about them? Let's see. Let's go. Oh, hang on, I don't want to add time. Let's go. Symmetric versus asymmetric. So they're down the bottom here in case you're unsure. Should be able to do this from the notes you just had on the board. Start with that, please. Start with that, go from there.
I've just done. I'm right. It's already been once. It's not really.
Okay, what do we got? Let's see. Let's see if any of you have been able to add more than just what I gave you. That'll be the answer. Do you know when it's best used? So I should already see what type of, how many keys are used. I should know the names of those keys. I should know which one is quicker or slower. I should know when the key is exchanged. Yeah? I should know how much data is it best used for. Someone says 6, 7 one more time, I'm going to start singing every time you do it. Go on. Go on. Every time you say it, till you stop saying it. Because then you look as stupid as I'll look.
Why are you pointing at me? I didn't say shit right.
Language. Okay. Okay, so this was one that people liked. So it's not incorrect. Good for bulk, which is correct. So this is correct, yeah? Oh, sorry, let me go back. What does that do? Allows me to move between them. Hang on. So this one here. So you are correct. In symmetrical encryption, you need to share the key first. Okay, which is problematic because if you share the key first and that key gets intercepted, then the data that was encrypted then can become decrypted and then you have a problem with the data. Okay? It's bad, you're correct. Absolutely. Okay, let's move on. So, the other thing we can do is called hashing. So hashing is where we convert data into a non-readable string, okay? And we can't reverse the process, okay? It means that we can stop things being tampered with. It means we can store passwords safely without revealing them. It is super handy in the space of security. So, on the count of 3, I want to know what is the best term for the fixed length output of a hash. 1, 2, 3. What? Star?
What is the best term for fixing output?
This would actually be, you know, when you log into CDP, would it be those circles that you see under your username for the passwords?
Yes.
Circles?
Like, you got your username on top, and then there's like a bunch of circles in the bottom.
Wait.
Oh,
It's
I'm
asterisk
like,
on your password.
yeah.
Yeah.
Digest is the answer. Correct. See? Hashing is a deterministic function that converts any input into a fixed length string called a... What is the best term for the fixed length output? Oh, I just got billed for Optus. No. Fixed length output of a hash called a digest. Thank you. Okay. So, in a way it is, but what you do when you when we do something called hashing, it's actually about storing them as well. Yeah? Does that make sense?
Yeah.
So what we do when we hash something is it's also the storing of the password, so that as a user in the system, in the back end of the system, I can't hop in and I can't see what everyone's username and password is. Yeah, as a programmer. Why would I want to do that? Privacy. Correct. So even if I have RBAC in place, which stands for what, Ethan? Emil? Even if I have role-based access control, which gives me permissions to be able to see the database, which has usernames and passwords in it, I still don't actually have access to view the passwords. Why would I not want to have that access? Or why would I not want, as a programmer, people to have that access?
It adds like a final layer of security just in case everything else fails.
Correct. It adds a final layer of security in case someone gets bought out, yeah? In case someone is a spy, in case someone gets turned, right? Does that all make sense to people? It's that last level of protection. But it then adds some other complexities. It means that we need to have some type of a function or process that does this. That when you log in, the function can compare whatever you've typed in and your hashed entry to the digest. Okay? Because we don't actually have the ability to know what that password was, yeah? Unhashed. Does that make sense, guys?
Yeah. So you can never decrypt it?
So, there will be a version of it, yes? I know. Every time I look over, I'm like, Emil's head's in the way. That's okay, Emil. You don't need to sit like that. I can just talk through your head. There is a version of it, but there's not a decrypted, an unencrypted version of it. Does that make sense? Yeah. Yeah. So we need to run a function against it that will do that process, that we then don't ever see the unencrypted version. Are we good about that? Do we understand what that means and looks like?
Yes.
Okay. Now let's talk about quarantining our code. And quarantining our code sits very nicely in the space of sandboxing. Go back, please. I'm going to give you a minute to have a look at your sandboxing notes. What do we know about sandboxing? Christian, you're looking at your sandboxing notes, please. Joel, you're looking at your sandboxing notes. Yeah, it is. It's a restricted environment. Why do I need a restricted environment, Joel?
So you can test that. So you don't have to put it out in the public and actually run the consequences, so you just test it. So you basically just prevent like any actual big problems from occurring. You just test what the capabilities of the software.
Yeah. So often, if you're working in industry, you have two different environments, right? Sometimes you'll even have a third. So you'll have sandbox, which is personal. I know, is there a problem with it being 25 past? Is there a problem with it being 25 past? Is there a problem? Daniel? Right. Then I don't need you to announce the time, unless your job has become clock in my class. Mate. Stop. Thank you. You'll often have 3 levels of environments running if you are a developer. So you're going to have your sandbox, which is a personal space. I spelled that wrong. Personal space. Yep, which means you're the only person with access to it. So you use that space to do all your initial development and your initial testing, just to check to see that your code doesn't go rogue and it works as you expected. You'll then release it into the development environment or your dev space. So in that space, it's going to have access to, and it's going to be set up as if it was real and live. But it's not real and live. Okay, so if anything goes wrong in that space when it's interacting with any other systems, it's not a big deal. Fully testable, fully checkable. and you run checks and tests in that space until you're 100% sure that it's not going to break anything, not going to steal money from anyone, not going to make anything or open up any vulnerabilities for your actual live system. And then once you've checked and run through that, then you release it to production or prod. Okay, and that's a process it runs through, because if you skip any of these steps and then you cause a problem with your system, it's very hard for the system to do something called rollback. What's a rollback? Yes?
Going back to an older version.
Correct. Installing a previous or earlier version. And sometimes you can't do that because it's made too many changes. In production, it's too hard to roll back. So rolling back's a really bad thing to have to do. If there are too many changes that are made, you want to make sure you run through your steps as easy as possible and you do all the testing you need to do before you put it into production. Okay? So if you don't have that written down in terms of how you do a release into the system, please make a note of it now. The other thing to consider is because lots of people will be pushing to development at different times, often they'll do a development clean. Because if you think about it, let's say Alan's pushing stuff to development and then Daniel's pushing stuff to development and then Joel's pushing stuff to development, and all of these different changes are being made in development. Often the development space isn't very clean and doesn't replicate what's happening in production. So they'll do a clean, take everything back out and reset development to like a clean state, so that you can then reinstall in development, and that's what you actually want development to look like. You want it to look as much or as close or as similar to production as it can, so when you install there you can get a close test to real life as you possibly can. Okay, let's go back a step. We want to now talk about that hash function that I spoke about. What do we know about this hash function? How can we best explain this to a group of people? So we've got the question on the board. A hash function uses a hidden key to turn a file into ciphertext. Anyone with the key can later decrypt the file back into its original form. You're going to write the explanation here. You've got 2.5 minutes. You got it? Go. Do we know what the word deterministic means? Deterministic. Have we heard that word before? No. Okay. Means A will always equal B. So it means it's always, so if I always say cat, I'll always get dog if we're talking about hashing. Does that make sense? So one thing will always lead to the other in a good hashing function, yeah? Which means we can always determine if what I put in as my password is always the correct password, because we always have one thing equaling the other. I don't need to do a decode. So go back, edit, fix. Do we need longer time? Oh, you already submitted? Oh. Really? I've still got an extra 30 seconds though.
Because I ran out of space.
Oh, okay. It's got a file cap on it. Okay.
Thank you very much.
8 seconds. Let's see if we know about hashing. Are we good? Okay, let's start voting. Oh, you're what? Are you voting? Oh. Yours blank? Okay.
Yeah,
Are you good? You back? 517468. There you go. Back in? Yeah, all good? Okay. 40 seconds. What are we doing? You're going to put it back? You spend more time in and out of my classroom than sitting in here. Come on. Christian, I need you focused and turned on, right? Come on. Okay, let's have a look. So let's have a look at what our best ones are. Sam is incorrect. It does not use a key and does not produce ciphertext. Instead, it generates a fixed length digest that uniquely represents the original data. It's one way, correct? It cannot be reversed, correct? And then it goes on to talk about encryption. Okay, so that is correct. Yes, it is one way. It's deterministic. A always equals B. Okay, which means we can do a comparison. If I put in A and I put it through the cipher, through the hashing, it will always produce B, which means if I put in A again and put it through the same hashing, it will always equal B, so I can check that I've got it right. Okay, let's have a look at this one. Sam is incorrect. A hash function does not use a key and cannot be reversed. That's correct. Generates a fixed length hash value from input, mainly to verify data integrity rather than to decrypt and encrypt. That's correct, but probably needs more data, more information in there, okay? I am happy with those. Oh, the third one?
Yeah, that one. I think whoever wrote that person.
Is it you?
I don't know. We don't have names.
Wow, that lesson went quickly, didn't it? Okay, let's just have a look. I don't need you to do that. That's fine. Okay, gentlemen, I'm going to stop that there. We'll stop that activity and stop.